is the landing speed of cat1 is greater than, less than, or equals to the landing speed of cat2. Now in this video we'll discuss the symmetry in the projectile motion. So consider that a projectile is launched with a speed of v0 at an angle theta above horizontal. Now the trajectory for the projectile would look something like that. It will go up, reach the maximum point, and then come back to the ground. Now the velocity in the x direction will be v0 cosine theta, and the velocity along the y direction will be v0 sine theta. This is vy, the component of velocity in the y direction. This is vx. And since we have considered that there is no air drag or there is no acceleration in the x direction, so this speed or this component of velocity in the x direction will remain the same, but this vy will change. And our interest is to find the expression for the velocity at the landing point. And before that, you should remember one expression that we derived in the last video, which is the time of flight. The time of flight is the time taken by the projectile to land after launching, which is given by t is equals to 2v0 over g times sine theta. This is the time of flight. Now the expression for vy is given by v0 sine theta minus gt. At time t equals to 0, the projectile is here. This is at t equals to 0, and if you put t equals to 0, the velocity for the projectile is v0 sine theta, which is this. Now what would be the velocity vy at this time? For that we can put this t here. So this would become vy is equals to v0 sine theta minus 2v0 over g times sine theta, and this g as it is. So this g and this g will cancel, and this is minus 2v0 sine theta, and this is plus v0 sine theta. So this would become minus v0 sine theta equals to, this is vy. And this is exactly the opposite of the y component of velocity when it was launched. You can see here, this is v0 sine theta, and here it is minus v0 sine theta. Exactly, the sign is opposite. And the x component for the velocity will remain same. This will be v0 cosine theta. But the y component, the magnitude will remain same, but the direction will be opposite. So this will be its direction. This will be v0 sine theta. So what would be the velocity? The velocity would be in this direction, like this. So we see that the projectile lands with the same speed it had when it was launched, but the direction is changed. So velocities are different. However, there is symmetry with the direction of motion. Let me explain this statement. The initial velocity is above the horizontal at an angle theta, and the landing velocity is below the horizontal with the same angle theta. This angle will be theta itself. This is above the horizontal with angle theta. This is below the horizontal with angle theta. Speed remains the same, but velocity is changed because this angle is changed. And this symmetry occurs at any level. That is, at given height, the speed of the projectile is same on the way up as on the way down. Let me explain this with a different diagram. So I have drawn this velocity vector for the projectile launch at the origin, and this dotted line represents the trajectory of the projectile, and I have considered these two heights, and this is the velocity vector of the projectile at this height, which is like this. And at the same height, when the projectile is returning, the velocity vector looks something like that. Now there is a symmetry here. What is the symmetry? The speed is same. Next, the angle theta. This is the angle theta above horizontal, and this is the same angle theta but this time below horizontal. And same symmetry happens to be here also. At the same height, the velocity vector would look something like that, and here the velocity vector would look something like that. The length of the velocity vector is same, but the direction is change. This is, let this angle be theta 1, and here also this will be theta 1 but below horizontal. So this is the symmetry. Now let the time of flight for this projectile is t. Then the greatest height is achieved at time t over 2. This is the greatest height achieved by the projectile, and here the time will be t over 2. The total time of flight divided by 2. And at this point the velocity vector will look something like that. There is no component of velocity in the vertical direction. There is velocity in the horizontal direction. So this is the symmetry in the projectile motion. And one most important thing is that all these results that we have explored are valid for projectile whose initial and final elevation is same. Now let's take an example on this. So this is example, and this is cat 1, this one is cat 2. Now both the cat jumps off the fence with equal speed. Let the speed for cat 1 is v0. So the speed for cat 2 will also be same, v0. But the difference is that both have different initial angle relative to horizontal. One cat jumps off at an angle 45 degrees above horizontal, and another cat, it jumps down with an angle 45 degrees below horizontal. This is the difference. Rest, the initial speed is same. Now what we have to tell is the landing speed of cat 1 is greater than, less than, or equals to the landing speed of cat 2. That is, when both the cats lands, this cat lands here and this cat lands here. So is the landing speed equal, greater than, or less than? This is what we have to tell. Now pause the video and try to think. Now let me explain the solution. Now from the symmetry of the projectile motion, we can say when the cat 1 returns to the level of jump at this position, its speed will be same as that of its initial speed. And further, cat 1 is moving downward at an angle of 45 degrees below horizontal, because here it was 45 degrees above horizontal. So here the cat 1 would be moving down with the same speed and at an angle of 45 degrees below horizontal. Now from this point, the motion for cat 1 and cat 2 is same. Thus the cat 2 and cat 1 lands with the same speed. So we can say that the speed of cat 1 will be equals to the speed of cat 2. Now think what would happen if cat 1 jumps horizontally like this with the same speed v0, but this time horizontally, or if it jumps at an angle of 80 degrees with the same speed v0, then will the cat lands at the same speed? Think. And the answer is yes, the speed will be same. In fact, for any given initial speed, the speed on landing simply does not depend on the direction at which the projectile is launched. This is a very important statement here, and I'll discuss this point again when we'll study chapter 8 in season 2. Okay, so this is all with this video, and in the next video I'll be taking one more example on the projectile motion, and I'll be covering the summary for the projectile motion, and that would be the last video on the projectile motion, the next one.